My name's Luca Padaracchia. I'm a senior production specialist at Side Effects Software, and today I'm going to talk to you about a new tool for labs called the Labs Post Animation Deform tool. The best way to kind of illustrate what this does is to just show you an example. So here I have a piece of geometry. It is an animated character, and it can be an animated cache that's like written to disk, or an alembic that you're reading in, or USD, whatever. And there are, in order to get this operator to work, you have to have a normal attribute assigned to it. And it needs to be a point normal. It doesn't have to be named normal. It can be named some other name. So if you have vertex normals and you don't want it to clash with that, you can name it to something else, like, I don't know, n_pt or something like that. And that the reason why you need the normal is the normal needs to is used to create a frame of reference or a matrix. And I'll talk a little bit more about that later, but that is a requirement. And the left-hand input is the animated geometry, and then the center input is the geometry at a rest frame, or some sort of reference model. And over here I have an edit that I've made, and just recomputed the normals on that, which you should do, because the normals, once again, are factored into how the orientation or the transform matrix is created internally. And then you just plug that into your Labs Post Animation Deform tool. Straight out of the box, you really shouldn't have to mess with the parameters. I'll talk a bit about what they do, but to get it working, you really don't have to fiddle with anything. And basically what this does, it applies the animation that has been made statically over here to your deformed mesh. And the nice thing about it is, if we come in here and look at this a bit closer, is this deformation is being deformed relative to the surface. So you can see that this bump here is moving with the kind of orientation of the surface. So it's following it quite nicely. And what's great about this is once you've done that, you can come down here and use, say, like a blend shape, and then kind of blend that into your original animation. Obviously, this isn't really a kind of a real world example, but the idea behind this is that take a situation where you have a character with a muscle and flesh sim, and you've simulated it, and it's taken a significant amount of time to simulate, and you show it to your supervisor or your director, and they come back to you with some notes, and very minor things like, on frame 64, we don't like the way the shoulder is bulging, or there's a kind of weird intersection that doesn't look good. You could go back and try and resimulate, or if it's a very small and simple change, you can use this post-animation deformation tool to kind of just model in that change for that one frame, and then blend it back in with the original animation to kind of fix it. So it's really kind of good finaling tool for doing this. And it's it's procedural, right? So you can make your edits over here on the right hand side completely procedurally. So if something changes upstream, you could compensate for it. In this case, I've used an edit, which is kind of not really that procedural, but there's no reason why you can't use some other modeling operator that's more procedural. So I talked a little bit earlier about the need for having a point normal on the surface in order to get this to work. And that's what this first parameter is referring to. This is the incoming normal that it's looking for. So as I mentioned, if you have a vertex normal or vertex normals, and you're like, I don't want to stomp over that, you can create a point normal and name it something else and refer to that, and this operator will still work. The other thing to note in terms of requirements and in order to get this to work is that you cannot have degenerate polygons. If you have degenerate polygons, it won't work. If your polygons are like super, super small, and there's an edge length of 0 on one of the edges, you'll run into problems as well. So that's a requirement, and you have to be aware of that. And the reason for that is, in addition to using the normal, the point normal to construct the matrix, it's also using one of the polygon edges to also create that matrix. And if that edge is of 0 length, then it won't work. Yeah, so that's a requirement as well. I'll talk a little bit more about some of these parameters just so you can kind of have an understanding of where they're at. The transform attribute is the internal attribute that is used to transform or deform the geometry. It gets deleted by default, but there's this option here to name it explicitly. The default here is to use $OS with underscore xform in the hopes that using the name of the node with this underscore xform will provide a attribute name that's unique enough that it will not clash with any upstream attributes. Or attributes that you want to pass on. So it's something to be aware of, but hopefully there won't be any issues with that. Attributes to transform. These are the attributes that you want to deform or transform with the internally created matrix attribute. By default, it uses position and normal, which are the kind of obvious contenders, but you may have other vector attributes on your geometry that you may want to get transformed along with the position and the normal. And then you have these two options here for delete transform attribute and transform geometry. And I can talk a little bit more about them in this example over here. So this is the example that's going to ship with the actual tool that you can refer to as an example. So here is just a very simple example, similar to what I showed you with the lion, pretty much the same workflow. Instead of using an edit SOP, though, I'm just grouping some points. So I'm grouping some points procedurally using a bounding sphere on the arm. And then I'm using a soft transform to transform it. You can use any modeling operation that you desire over here. And if you make those adjustments procedurally, if your input changes, those adjustments will take place automatically. But back to what I was discussing earlier, this option of, deleting the transform attribute and transforming the geometry. It may not be obvious, like why would you want to have this operator but not transform the geometry? Well, this little example is kind of meant to answer that question. So here we have one modeling operation, which was just this, bump being pushed off the arm. And over here we have another modeling operation. And here I've just created a attribute um, that is been driven with some noise, and it's pushing out the geometry a little bit. So, and both those guys get fed into this post animation deform tool. But both these operators have the delete transform attribute turned off and the transform geometry option turned off. So what is happening, or what's the significance of this? If we look at this, we can see that we have these two transform attributes, subnet 5 xform and subnet 6 xform on these two different nodes. I'm going to copy subnet 6 onto this other geometry. So now we have them both living on the same geometry. And then I'm going to use this transform by attribute node. And these are the attributes that I want to transform, the position and the normal. And I want to transform them by this subnet 6 xform attribute. So you can see that it's picking up that, doing it. And then down here we have the geometry, and we're taking that and transforming it using this other matrix attribute that we've created over here. And now you basically have the two of them combined. So that's basically, and you can bypass one to see the effect without it. So that's basically the one of the options in terms of using this tool. You can apply the transformation after the fact with this transform by attribute tool. And as a matter of fact, if we come into the node, go allow editing contents, and we look inside it, that's basically what's being done. Is it's got this transform by attribute tool, and that's how it's doing the transformation. One thing I'll point out, just kind of about the mechanics and how this tool has been created. If you are, have, are a little curious about matrix and transformations and how they work, this node is a really great example of how matrices works, in a really kind of like nice practical one. So by reviewing or looking through this kind of operator and how it works, you can get a little insight into how you can create some matrices and how you can basically record transformations. So yeah, if you're at all curious about that, I encourage you to kind of crack this open and take a look. Anyways, so that's it for my synopsis. I hope it proves useful and you have some fun with it. And I look forward to hearing your feedback. Thanks very much.